Howdy, my name is Maddie Foster and I'm the captain of the Women in Engineering VEX U Robotics Team, a non-capstone project team. We will introduce you to our team, show our mechanical design, explain our programming development, and our goals for the 2020-2021 year. We welcome students of all classifications and majors and do not require any previous experience or knowledge. We strive to provide students with the opportunity to gain technical skills and develop professional competency in an inclusive environment with the annual VEX U competition. For the fall 2020 semester, we were limited to virtual meetings, so we had to find new ways to collaborate and design. Because we did not have access to our materials or our building space, we held team meetings through Zoom 3 times a week and offered additional workshops and Q&A sessions throughout the semester.
Howdy, my name is Catherine Rosas and I'm the Public Relations Officer for VEX U Robotics Team. Regarding the team breakdown, the VEX U Robotics Team is separated into 2 sections, the big robot and small robot. Each of those sections then has 2 subteams, mechanical and programming, with respective leads. The subteams of the big robot are comprised of experienced members, while the small robot is comprised of newer members. Both subteams will work together to create functional robots for the VEX U competition.
Howdy, my name is Kalata Stadler and I am the project manager for the VEX U Robotics team. We use this Gantt chart to schedule our tasks for the year and keep ourselves on track. This schedule was designed over the summer on the assumption that we would meet only virtually in the fall, but possibly be able to physically build the robot in time for a virtual competition at the end of February. This is why our teaching and design focused tasks are scheduled before winter break and implementation and testing are scheduled afterwards. This chart is broken up into different sections to track meeting plans for the general team and each of the subteams. In our VEX U program, we teach new members everything they need to know to significantly contribute to the robots. The subteam leads design a curriculum to teach the necessary skills, and that curriculum is also scheduled here.
Howdy, my name is Sam Matthew and I'm the team's historian. Here are the rules for the 2020-2021 VEX competition change up. The playing field has 9 goals arranged in a 3x3 matrix. Each of the 2 teams is assigned either red or blue balls, and they must use their 2 robots to score their balls into the goals to earn points. The team with the most points wins. Each match will consist of a 45-second autonomous period where the robot may not be controlled by the drivers. Then there's a 75-second driver control period where the drivers can control the robots. Robots can score balls by putting them in goals or descored by removing them from goals. At the end of the match, each team is awarded 1 point for each of their colored balls scored in a goal. 6 points are awarded for each row, column, and diagonal of 3 goals where that team's ball is a top ball. In the autonomous period, points are also awarded to teams for completing their row and having the most balls scored.
Howdy, my name is Cassandra File and I'm the mechanical lead for the VEX U Robotics team. Considering the lack of interaction with the team this year, we were still able to meet over Zoom to discuss the main goal of the VEX U competition and how we'll be able to overcome it with our robots. We followed the approach of the engineering design process by coming up and sharing ideas as a team and then use the decision matrix to choose the best option that will look for our robots and for the competition. For the decision matrix, we broke it up between 2 sections. The first one is just about drive bases and the second is all about ball intakes. For the decision, we brought these designs into a 3CAD program called Tinkercad to see if there were any parts or formations that would not work on the robots in real life.
Howdy, I am Lorena Martin. I am the second mechanical lead for the team. For this year's design, we understand that this competition is fast-paced and that we need robots that will be able to score quickly and efficiently. So in order to achieve this, we considered a robot that can both input and output the balls quickly by utilizing a shooting mechanism that can easily reload from the bottom, then shoot out from the top of the robot. While creating the design that is seen on the screen, however, we came across some issues and took steps to correct them. Many of them had to do with the size restriction enforced by the competition itself, where we found that trying to cram everything into a smaller size was not necessarily the most efficient plan. One example would be that the motors near the initial intake, represented by the boxes, were far too close together and would not allow the game elements to pass through. The solution that we found was to expand the width of the robot in order to both keep it square and allow there to be more space between the motors. By modeling the design, we were able to see these issues before we actually began to build the robot, thus saving us plenty of time for the spring semester.
Howdy, my name is Saini and I'm a member of the mechanical subteam. The small robot design is similar to the big robot because they share the same goal of placing as many balls into the hoop as possible. The two major differences between the small and the big robot are that the design restraints on the smaller robot being 15 by 15 by 15 inches, and that the two robots have different styles of drive base. The big robot will be using an X drive and the small robot will be using a modified H drive. We chose the drive base style using a decision matrix focusing on 4 criteria. We found that the standard design of a modified H drive with the 4 Omni wheels to be the best option to save space under the design restraints. We also considered the restraints while planning the ball intake design. Based on the design criteria, the curved ramp with the rubber bands was also the best option among all the shooting mechanisms.
Howdy, my name is Isabel Sanchez and I'm a member of the VEX programming subteam. The programming team takes the mechanical team's design for the robot's capabilities and creates code to bring them to life. We create code that takes care of the robot's movement, intake, and autonomous routine. In general, the programming team follows the workflow of first understanding the robot's design and intended functionality. Then, in order to code the robot in a timely manner, we break down the design and split the work among topic groups. Each group then works together using PROS, an open source operating system for VEX V5 and C++. But by using GitHub and Git, the team is able to collaborate and design code for the various functions of the robots.
Howdy, my name is Sarah Beltran and I'm another member of the VEX programming subteam. Within our programming team, we have 4 subteams: the big robots autonomous and X-drive teams, and the small robots autonomous and intake teams. Each of these teams are vital in helping us work together to produce the best quality code for the robot's autonomous functionality. Our autonomous team for the big robot is working on creating a code that will help give our team the most efficient and effective techniques for intaking and scoring points within our 45-second frame.
Howdy, my name is Anna Huang and I'm a member of the VEX programming subteam. The Big Robots X-Drive subteam specifically researches and provides the team with the code behind driving an X-Drive design for the robot's wheels. The Small Robots Autonomous team works similarly to the Big Robots team in providing the code implementing the bot's autonomous strategy, yet it does so with the specifications of the Small Robots intake and movement. The Small Robots intake team is working on creating a function for the small robot to be able to take in the game balls and move them about.
Howdy, I'm Melissa Zhang. I'm one of the programming leads for VEX U. We have broken our strategy into 2 phases. Our primary goal for the first phase is to complete the 3 goals bordering our side for 7 points. In the second phase, our goal is to then completely score the middle goals. To avoid unintentional contact with the opposing side, the use of this phase will be when the opponent doesn't approach the middle goals or balls. Since the competition can assign us to the red or blue alliance, our plan must have concise code that can be easily inverted depending on the starting color we are assigned.
Come spring 2021, there are several factors that will need to align in order for us to be successful in our building plan. We are dependent on the College of Engineering allowing us to meet safely in small groups and to have access to the Fisher Engineering Design Center. Assuming that all of these provisions are met, we are hopeful that we can complete a speedy build using the dimensions and functionality developed in the 3D designs for our big and small robots.
After building our 2 robots, we will undergo intensive unit testing. This will include analyzing the reliability of our autonomous routine, comparing the physical build with the CAD to ensure we are meeting our initial design goals, and ensuring that our final dimensions are within size restrictions. To finish the VEX U season, we will compete virtually in a regional competition.
Finally, we would like to thank our sponsors for their continued support and would like to thank you for learning about the VEX U Robotics team. Thanks and gig 'em.